Hello and welcome to a special episode of It's Not Rocket Science, the podcast from the Innovation Launchpad Network, which shines a spotlight onto our researchers in residence. A rather apt title today because I'm joined by Andrew Ross Wilson from Glasgow Caledonian. Andrew is a researcher in residence from our first tranche, and the discussion on today's pod is about space sustainability and how the sector needs a radical rethink.
Stand by for a lo-fi, low quality and low budget transition into the main part of the podcast.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Okay, so Andrew, I guess introduce yourself to our thousands, millions of listeners.
Yeah, so my name is Andrew Wilson. I'm a lecturer at Glasgow Caledonian University. I recently moved there from the University of Strathclyde, where I was at previously. And my work really revolves around space sustainability. So I've been working for the last decade or so, particularly on life cycle assessment and eco-design of space systems, which essentially is looking at the environmental footprint of a space mission from, across its life cycle. So from the minute you extract resources from the ground and start designing it, through the production, the testing, the transportation, the launch campaign, even the use, because even though it's in space, you still have ground stations, which are quite energy intensive, and then ultimately the end of life as well. And that's something I've been working on for, as I say, about a decade, where at the minute I lead various working groups such as the European Space Agency's Life Cycle Assessment and Eco-Design Working Group. And now I'm also looking at kind of carbon accounting, which is very similar to life cycle assessment, but slight variations, and particularly to get more of an understanding of what is the space sector's contribution to kind of global warming or climate change, particularly given that when you see a lot of how do I put it, figures talking about aerospace, actually you'll find that the space part itself is actually missing. So that's been kind of what I do in a nutshell.
So what attracted you to that kind of corner of research? I'm most fascinated to see how you kind of end up in these really kind of niche areas.
So it actually goes all the way back to my undergraduate, where when I was was at Glasgow Caledonian University for. So I've kind of gone full circle, in the sense that the course I was on as an undergraduate is now the one I'm teaching on. But during kind of my end of my third year into my fourth year, we were obviously had to propose a dissertation topic, and one thing that kind of tickled my fancy was whether space technology could be used to address climate change, but looking at it from a bit more of a practical point of view. So rather than the traditional form of using space data to inform our decisions, can you actually have practical technology such as space sunshades or solar power satellites? And when I was doing my research for this, one of the big findings I found that although those technologies claimed to have environmental benefits, they actually couldn't quantify their own environmental footprint. But this wasn't just refined to those technologies I looked at. This was a sector-wide problem. So because of that, the dissertation got a lot of interest. So after I graduated, I went and worked for the United Nations for a while. But whilst I was over there, this was kind of gathering in the background, and eventually a little bit of funding was put on the table for a PhD to explore the topic further. And that's what I did. So I came back to Glasgow, went over the road to Strathclyde, and did my PhD there, and then continued working on it even after the PhD concluded.
Brilliant. So how has it got to the point where it's the space industry has kind of not had these considerations? Is it? I read that there's some exemptions for the space industry when it comes to it.
Yeah, so the space sector has been overlooked by a lot of key legislation. So you can go even further back in time to even when the Montreal Protocol came about. So that was implemented to essentially phase out chlorofluorocarbons after the ozone hole was discovered. And it actually missed out the space industry, despite the fact that rocket launches are the only form of man-made pollution that will actually inject ozone-destroying compounds directly into the stratosphere where the ozone layer resides. So it's been overlooked in that sense, but you're right in what you said. There has also been key exemptions in various bits of legislation, even at a European level, the WEE directive, the Restriction of Hazardous Substances directive, all grant exemptions to the space sector. So that has essentially meant that the space sector hasn't really had to care all that much about their sustainability. And as a result, the space sector has fallen, in my opinion, quite far behind other sectors. They only actually started looking into like life cycle assessment as recently as 2009. That was the first time it was even thought of as a concept for the space sector, which is really far, decades behind every other sector. But even the terminology we use in the space sector is completely misaligned to every other sector. So a good example is the term high performance green propellant. Now, that term means that the propellant simply is not toxic. It doesn't mean it's environmentally friendly or green, as it would do if you'd used that term in any other industry. And in fact, the European Space Agency and I did a comparative analysis in 2018, where we compared the traditional propellant hydrazine, which they're trying to phase out through REACH, with a high-performance green propellant. And we actually found that the high-performance green propellant performed environmentally worse in 13 out of 16 environmental impact categories. The only three that obviously it did perform better on was the toxicity ones, because obviously it's lower toxicity. But the point I'm making is that even our terminology is misaligned. And, you look at kind of carbon footprints, LCAs, they're still very much developing in the space sector. The space sector is still trying to very much find its feet because of how far behind that legislation, that oversight has done in the past.
I suppose it's. I mean, I'm going to use two American examples. Obviously, this week there was the Boeing Starliner, and also Elon Musk. I can't remember what his project is called, but those projects have been, particularly the Boeing one, that's been going on for 7 years, and it makes me wonder what is the carbon footprint of that project? It must be huge, considering all the tests, all the relaunches they've had to do.
Yeah, so I mean, I was actually at yesterday and the day before in Edinburgh. We were having a meeting about space sustainability, but mostly from a policy context. And one of the panel discussions was on space launch, and we were talking about it from a UK context. And of course, we've not had any launches from the UK yet, but this is an upcoming thing with the opening of spaceports all over the place. But the danger very much from that panel, which I voiced, was that people are getting too lost in the impact of launch. I mean, don't get me wrong, the impact of launch is going to be very great. But if you're only focusing on reducing emissions from that particular phase of a life cycle, what you could have is essentially a burden shifting effect. So yes, you might lower your emissions from the exhaust products that come from the launch event, but you might have higher impacts across your production and manufacturing of the launch of the propellant, the storage, the decontamination, that general handling, etc., even the launch campaign itself. And I think there's another quite interesting concept is we're seeing a lot more reusability for launchers, which is of course a good thing, but it's not as inherently better as you may think, because in order to land the stage again, you need more propellant. You need to produce that propellant, you need to store that propellant. Again, propellants can be quite toxic. You then need to go and recover the rocket. You need to then take it back to your base. You need to return it to space grade, which is energy intensive. So it's not as inherently better as, I mean, it is, but it's not as much as a golden solution as everybody may think it is, because when you consider everything about it. But going by what you were saying with SpaceX, we're in this unique position where when a lot of our space laws were actually written, it was before sustainability was a concept, and it was before private entities were getting involved. And we're now entering this kind of era where we're entering uncharted territory. Every year, there's more and more launches. I mean, last year, for example, we broke the record for the most number of launches in a calendar year. We're going to likely break that again this year. And of course, that then scales up industry operations. And you might get to a point where the space sector actually can't justify the good it's doing anymore. So we call this kind of the space sustainability paradox, where the more things we try and put into space to positively contribute to sustainability, actually the less sustainable we're being, both from the terrestrial environmental point of view, but also in space by depleting our orbital space capacity and and adding to the space debris population that's already there.
I was going to say it's obviously this is going to be more and more important now. There's more commercial. It's not just NASA. It's Elon Musk. It's Bezos. They're all getting involved, aren't they? Sending rockets up there. So this is going to be more important as the years go ahead.
I think when we even look at satellites, when I first started doing this research, one question I asked was, what about re-entry of satellites? What happens in that sense? And they went, it doesn't really matter. The more meteorites re-enter than satellites anyway, it doesn't matter. But now we're talking about mega constellations of thousands of satellites.
Yeah.
And you could essentially be creating a rain of re-entering objects. And this, let's be clear, this isn't just rocks that are re-entering. This is metallic and electrical compounds, which very much could change cloud behavior in the upper, from the upper atmosphere as it filters down. And it's very, very poorly understood. And you see a lot of guidelines in the space sector now, such as the IADC guidelines, which say that at the end of life, spacecraft should re-enter within 25 years. That, to me, is not managing the problem. It's simply shifting one form of pollution to another. And really, for me, for the space sector to be sustainable, particularly in the direction it's going, we really need a radical rethink of what we're doing. And again, the trouble is it's a very fast-moving sector. And by the time you could implement a law, aimed at space sustainability, the sector could have moved much further away, and it's no longer applicable. It takes, up to about a decade to get a law in place from initial discussions. Wow. So it's very, very challenging.
It's frustrating. I thought it was bad at universities, but yeah. Moving on. So I would imagine your project with Satellite Applications is your research and residence project is going to aim to address this. Could you give us a little, I guess, a brief bit on how that's going and your findings so far?
Yeah, absolutely. So the project that specifically I'm looking to do is to baseline the carbon footprint of the UK space sector for the first time, and to do that, the idea is that we're going to kind of create a carbon footprint report for specific companies in each of the different cluster regions across the UK. Now, the reason this is, I would say, an important project is because, simply put, carbon footprinting hasn't really been done at a sectoral scale for the space sector at all. I mean, there was proposals in France to do it, which kind of fell through. A couple of companies here and there have done it. In Scotland, we have actually done that on a few companies as part of the Scottish Space Sustainability Roadmap, which I was fortunate enough to be the science lead on for that project. So the idea essentially is to work out, use that data, extrapolate it, and work out, approximately speaking, what the carbon footprint of the UK is, and identify potential areas where we can decarbonize as well. So hopefully that could lead to at least inform politicians, if not form policy. But so yeah, that's what the project wants to do. In terms of where I'm at with it, we're at the point where the kind of the literature review stage is just about concluding. So at the minute, I have been looking into the net zero context of the UK, the kind of the policy for space. And it's very complicated because, of course, when we're talking about space. Space very much is, a power held by Westminster, whereas when we talk about the environment, it's devolved. so which adds kind of complications to it. So sort of looking into that, looking at what's been done previously, I suppose one of the biggest findings for me has very much been that the UK has been very good in the past at setting targets for climate change.
Yeah.
It's been very bad at actually implementing the transformative policy package that has been needed to actually meet those targets. And when it comes to the space sector, it's actually even worse in terms of there is just nothing. So as I say, the next steps for this project now is to start kind of reaching out to different countries with the Satellite Applications Catapult, of course, to try and gather interest in the project. The benefit to the company, of course, being that they will benefit from a free carbon audit report, which would tell them about their emissions within their own company and provides recommendations to how they could decarbonize at low or no costs, and point them in the direction of potential resources that they could use to help them, whether that be training or funding schemes or whatever else. And then, of course, we can use that data anonymously, of course, as part of this wider analysis.
Well, thanks, mate. Yeah, this is a really interesting project. I was going to say, how has the scheme helped? But I suppose it sounds like you're quite advanced and you've got, your fingers in all the correct pies. But I guess how has the scheme helped just for our own kind of ego in a way?
For me, firstly, the funding has allowed me to kind of continue doing this project, because as I said, I was in Space Scotland. I was kind of science lead, but it was a UKSA cluster funding project. So it essentially has allowed us to take what we've learned in Scotland, grow it even further, and then offer it wider across the UK. So it becomes something that the UK can benefit from rather than just Scotland. But also, I think that for me, the most important thing is the collaboration. So I've really enjoyed working with the Satellite Applications Catapult, and I think as well it's also been beneficial for me to access their network, because I've got no doubt that up here in Scotland, I could get enough companies to run a study for. But when it comes to other areas across the UK, I maybe don't quite have as many connections there. Yeah. So being able to kind of leverage their network for this project, I think, has been very beneficial. And also to have experts who are in from other areas, it makes you kind of think about things from a different perspective that you maybe haven't thought of before, which I found kind of quite interesting perspectives as well.
That's quite a common thing I've heard from speaking to researchers and residents, that when they speak to other experts at any catapult centre, they're working on different projects, but that they kind of allow you to think in a different way and maybe apply a different tact to it. So I've got one last question. I'm just adding this to make it a little bit lighthearted, just because it can sound a little bit depressing in a way, because it's a bit like we're continuing to destroy the planet before we even manage to colonize anywhere in space. But I'm going to copy the Infinite Monkey Cage and ask what is one scientific discovery in the space industry that you wish you'd made?
Oh, that's a difficult one.
I should have prompted you. I should have given you a little heads up on that one.
Yeah, that's a very difficult one to say, and I'm not too sure of the answer. I mean, don't get me wrong. If there was one that I wish I'd made, maybe for the work I do, wish I'd maybe gone to the LCA study first in 2009, but that would never have been likely to happen, because in 2009 I was still doing my S4 exams in high school, so so it was never likely to be me. But yeah, it would have been quite a cool thing, if I would say, for me to have done that first. I mean, the good thing is that because I am one of the first researchers in that field, I have become one of the go-to. Because I remember when I was doing my PhD, I got halfway through it and I thought to myself, am I specialising here in something that just nobody cares about? Yeah. And it was very lucky that just as I was finishing, there was this explosion of interest in it, which has got me to where I am. But to answer your question, probably that. but it's a hard one to say, because there've been a lot of such interesting discoveries in the space sector, isn't there?
Yeah, definitely. Okay, I'll take that. Thanks so much for your time, Andrew. Really appreciate it. Sounds amazing, and we'll catch up. We'll catch up in a few months and see where you're at.
Absolutely. Thanks for the time, and have a good weekend.
Brilliant from Andrew there. Really excited to hear the outputs of his project with Satellite Applications Catapult. Clearly a very established fellow in his field. That's all from us this month. You can catch us on our usual socials of Innovation Launchpad Network Plus on LinkedIn, Twitter /X, and YouTube. But for now, I'll see you next month. Bye-bye.